All right, so we are going to start actually calculating pH, and this is just going to cover page 6, but I would really recommend that you have a calculator that has a log button on it, and hopefully it also has a 10 raised to the X button. Those are the two special things we're going to be doing in our calculations today, and I'd really recommend you calculate along with me instead of just writing down the numbers so that you can know if you can get these same numbers yourself. If you can't, then let me know and I can help you fix what you're doing in the calculator or how you're typing it in. So at the top of the page, we have our pH scale. And I know we've talked about this a little bit in our previous notes, but it's actually the top part of that line that is the actual pH scale, going from 0 to 14 with 7 in the middle. We can actually go beyond 0 and 14. We do have bases that are more basic than 14 and acids that are more acidic than 0. This is just kind of the classic range that's usually presented. And in the middle of that is neutral, of course, not an acid or a base. And hopefully you remember from prior notes that our acids are the ones that are on the lower side of our pH scale, and the bases are the ones that are on the bigger side of our pH scale. That is what you need to know for classifying substances. We're always going to bring it back to this pH scale and use those pH numbers in order to be able to classify our substances. But technically, there's this other thing called the pOH scale that kind of corresponds to our pH scale. It's just kind of sort of the opposite. Where our pH scale is at 0, pOH is at 14. When our pH scale is at 14, pOH is at 0. So these are related scales, and we are going to be calculating the pH and the pOH here in just a little bit, but we're always going to bring it back to the pH in order to classify substances. And that's one use of these numbers, but we can also use all of these numbers in order to figure out more information about our solutions, like what is the concentration? And what you might notice here, so I pointed this out that, where pH is 0, pOH is 14, but even in those decimals in between, they're always going to add up to 14. So that equation is going to help us convert between our pH and our pOH scale. And the last two equations that we're going to use right down here, technically there is that one other equation that we can use. I'm going to show you in just a minute why I don't like using it, and part of it really is that scientific notation part that it has there. So these two equations that are below our pH and pOH equations are actually pretty important. Not just to tell us to do 10 raised to the negative pH if I'm looking for the H plus concentration, but because this also establishes something that I call the exponent rule that we're going to need. If we have a concentration, whether that is our H plus concentration or our OH concentration, and it's in this standard form, 1 times 10 to some number, then that exponent, well, really the negative of that exponent, because it's probably going to be a negative number, that is going to be either your pH or your pOH up there. So basically, we don't have to put things into these equations to calculate our pH and our pOH. If the H plus number that we have has 1 in its base, then the pH that we're looking for is just that exponent up there. And same with our OH concentration. If my OH concentration has 1 as its base, then the pOH is going to be that exponent number right up there. So this is going to help us if we're in that form. If we're not, then we're going to need the calculator. But this is a really important rule that'll save you a lot of time and calculation in estimating or finding that pH. So off to the side, about halfway down your page, you have a map. And I wanted to kind of fill out this map just a little bit because a lot of people get confused by all of these different equations. And unfortunately, the only equation that you're really given on your equation sheet that's going to be useful is going to be this one. But I want you to notice that if we're using that equation to calculate our pH from our H plus, so that would help us go from left to right, then the same equation is sitting here to calculate our pOH, and we saw it up above It's the exact same equation. The only difference is we're finding the POH instead of the pH, and we're taking the negative log of the OH stuff instead of the H stuff. So it is the same equation, it's just helping us with the OH information instead of with the H information. So we can get to POH or pH from our concentration of H and OH. We just need to make sure that that matches. If we take the negative log of one of these ions, we're going to get the P of that ion. And then we're doing 10 raised to the negative pH. If we wanted to calculate the H plus and we have the pH, then we do 10 raised to the negative of whatever that pH is, and that'll get us our H plus value. Same thing happening down here. If I want to find my OH concentration, I do 10 to the negative POH in order to get that. So those equations are going to be kind of your bread and butter. That's your back and forth that you need to know, how to take a negative log and do 10 to the negative of a number. And yet we might have some calculations, some problems that give us some OH information and maybe ask us to find a pH. So we have to be able to bridge this gap. And technically there are two different ways we can do that. But the one I'd really recommend that you use, that it isn't written on the equation sheet, but it's so easy to remember, is that 14 is always going to be equal to the sum of the pH and POH. So if I was given OH concentration and asked for the pH, I could turn OH into POH and then do 14 minus that POH to figure out what my pH is. Same thing if I was given my H plus concentration and asked for my POH, is I could find my pH from that and then find my POH. And that's what I would really recommend we do. Now, technically, over here on this side of our map, we have that 1 times 10 to the negative 14th equals the two concentrations being multiplied together. So technically all we'd have to do is 1 times 10 to the negative 14 divided by whichever concentration we have, and it'll give us the concentration that we're looking for. I only use that equation if I'm trying to get straight from one to the other, because everything else, even if I'm trying to just get over here, like I said, I know how to do this real quick, real easy all the time. And then subtracting from 14 is so easy. It's so much easier than dividing by some big scientific notation number. And I'll be honest, students tend to mess up putting these in the calculator and then they get wrong answers just because they're being sloppy or they don't know how to use the calculator well, not that they don't know how to do the calculation. So I would really recommend that we not go this way. That in our map, we just focus on going, even if we have to, all the way around here in order to get to our answers. But technically, because this is a big circle, there are two different directions you can solve any problem, even going from H to pH. This is what I would think you could do, but you could technically go all the way around here. And as a result, if you do it in 3 different steps, your answer might be rounded a little different. So keep that in mind if you see the answers that I've posted online, is that the rounding might be a little different depending on which direction you go with your calculations. So let's actually do some calculations here. I'm going to focus on these 2 first equations that we have here. How to find our pH by taking the negative log of the H plus concentration, and the fact that that H plus concentration is 10 to the negative of the pH. And remember, we can only, we can use a shortcut for these first 2 problems because they both have 1 as their base. The shortcut, that exponent rule that I talked about, as long as we have 1 as our base here, then our pH is just going to be the negative of the exponent. And since those are already negative, that pH is going to be a positive 9. And our H plus, our second example, our pH is 6. Just literally pulling that number off of the exponent, that's our answer. You can plug it into the calculator and take the negative log of 1 times 10 to the negative 9th as well, and it'll tell you 9. So you can do it the long way, but if you notice that base of 1, then we can get it a lot quicker and easier. And now if we're trying to find our type of solution, if you have a pH of 9, that's bigger than 7, that's going to be a base. 6 is less than 7, that's an acid. Quick and easy after we have our pH. Now on these next 2, we cannot actually use that shortcut rule. we can look at those exponents and realize that 9 and 6 are close to what they're going to have, but it's not going to be quite exactly 9 or quite exactly 6 because our base over here is not 1. So for these, we are actually going to have to plug in negative log of 7.45 times 10 raised to the negative 9, or if you want to type that in as 7.45e negative 9, I would recommend it. Either way, we're taking the negative log of that number, and if we do that, then 8.13 is what comes out, and that's our pH. If we take the negative log, that is still a base, so its pH has changed a little bit, but it is still kind of sort of close to 9. On that next one, negative log of that 2 times 10 to the 6th gives us 5.70. Once again, it is pretty close to that exponent of 6, just not quite. So that we have to keep a lookout for those bases and whether or not they're equal in 1 or whether there's something different. Doesn't change the overall value much, but enough to be significant. So that's most of what we're going to be doing. In this next chunk, we're kind of doing the opposite, but notice our pH in that first row is a nice even round number. So when I'm putting together my H plus concentration, we can just put it in that same form that we saw before, making sure to make it look kind of sort of scientific notation-y with that 1 up front, then just do times 10 to the 4th, because that's what our pH is. Now technically for the rest of these, so we're doing 10 to the negative 4. If you put that in your calculator, it'll probably tell you in standard form that your concentration is this, and that is absolutely fine. That is equivalent to this. Now the one thing we have to keep in mind is if we have something like this that has a decimal, technically our answer is 10 times 10 to the negative 4.15, but that's not proper kind of scientific notation. We can't have decimals in that exponent. So you have to plug anything with a decimal, anything that's not a whole number, into your calculator. We can't just leave it in this form and do, to the negative 4.15. Not an accepted number. So we just need to put it in our calculator, and then our calculator tells us that 10 to the negative 4.15 is 7.08 times 10 to the negative 5. If we do the same for 7.23, 10 raised to the negative 7.23, push enter, that's 5.89 times 10 to the negative 8. That's our answer. Same stuff happens with our OH getting turned into the POH. With these first two, because they're nice round 1 times 10 to the something, then that something is going to be our POH. So 9 for our POH for the first one, 6 for the second one. These next couple are decimals. We've got to plug them into the calculator, which means we're actually doing that negative log thing. So taking the negative log of each of these numbers, being careful to plug that in carefully, we get 8.46. Once again, a little less than 9, but pretty close to 9, and 5.22. In this next chunk, we're doing the opposite, going from our POH to that OH concentration. And once again, those first two are nice round numbers. So when we're putting that together, we can just do 1 times 10 to the negative 3 and 1 times 10 to the negative 9. These other two we're going to have to actually put into our calculator and do 10 raised to the negative 8.55 and 10 raised to the negative 4.83. But once we do that, push enter, then our concentrations come out. So it really is mostly negative logs and 10 raised to the negative. Now, these last two sections, just like I showed you on the map, we have our pH is what we're starting with, but I want my OH concentration. Notice how my H and my OH do not match. That means we're going to have to convert between the H side of our map and the OH side of our map. And I'd really recommend we use that fact that they add up to 14 to do that. So when I'm trying to go from pH to OH concentration, I'm really going to take a quick stop in the middle at the POH. I want to find all these POHs because then it's trivial, just like we just did, to get from our POH to the OH concentration. We just need to do 10 to the negative, just like we were just doing. So here we're going to do 14 minus our pHs to find those POHs. So if we do that, 14 minus 14 is 0. 14 minus 2 is 12. 14 minus 8.2 is 5.8. I want you to go ahead and finish up that last row. So now that we have our POHs, we just need to do 10 raised to the negative of each of those. So 10 raised to the negative 0, well, 10 to the 0 is just 1. Anything to the 0 is 1. 10 to the negative 12th is going to be 1 times 10 to the negative 12th. 10 to the negative 5.8 in our calculator is 1.58 times 10 to the negative 6th. So just an extra step there at the beginning before we go from that POH to OH. Everything else is the same. Make sure to finish up that last row there for a stamp. And in these last two here, we're kind of doing the opposite. We're going from our OH concentration to pH, but once again, notice how they don't match. I have my OH stuff here, my H stuff there. So we're going to have to do this in more than one step. First step is going to be to turn our OH into the POH, which is going to mean taking the negative log of that OH concentration, and then we can do 14 minus that POH in order to find our pH. So I'm going to do this first one for you. Negative log of 2.5 times 10 to the negative 5, as you might assume, is pretty close to 5, but not quite. Then we subtract from 14, and we get our pH is 9.4. And now that we have that pH, it's bigger than 7. That's a base. So go ahead and finish this last row. Let me know what questions you have when you get to class.